Namaste everyone, welcome to Millionaire GRE. I am Punit. This is the sixth video on statistics, and in this video we are covering the concept of quartiles. Let's say you are given these set of values. Let's find the median of this set or this list. Here the terms are arranged in ascending order. You can find the median by taking the average of the two middle terms, because there is no particular middle term here. You will take the average of two middle terms. Here median is 12.5. Now median divides any data set, any list, into two parts, into approximately two equal parts. Quartiles divide a data set into four parts. Quartiles divide a data set into four equal parts. Now there are three quartiles. Quartile 1 is the median of all the terms below the median. Median of all the terms below the median. So median of the first four terms, here is 4, so that is quartile 1. Quartile 2 is median itself, and quartile 3 is the median of all the terms greater than the median. Median of the last four terms is 25, and that is quartile 3. Now you see, median divides the data set into two parts. This was one part, this was the second part. But quartiles have divided into four parts. 3 and 4. Median divides a data set into two equal parts. Quartiles divide a data set into four equal parts. Now we say median is at approximately 50th percentile. Now, that means approximately 50% of the terms are below median. Here you can see 4 out of 8 terms are below median. Hence median is at 50th percentile, because 50% of the terms are below median. Quartile 1 is approximately at 25th percentile, because 25% of the terms approximately are below quartile 1. Similarly, quartile 3 is at approximately 70th percentile. One more thing, interquartile range. Interquartile range is simply the value of Q3 minus Q1, quartile 3 minus quartile 1. In this particular example, interquartile range is 25 minus 4, that is 21. IQR or interquartile range is simply Q3 minus Q1. One last thing. Sometimes by quartile 1 or by first quartile, the question means the first quarter or the first 25% of the terms. Similarly, the second quartile might mean this, the second quarter. Third quartile might mean this, and fourth quartile might mean this. Now you have to interpret the question and understand what does it actually mean. Quartile 1 might mean this particular value, which is the median of all the terms below the median. The first quartile might also mean the first 25% of the term. So quartile 1 or the first quartile can have two interpretations. Similarly, quartile 2 might mean median, might mean the second 25% of the values. So yeah, it depends on the question. And to find the quartiles, you have to arrange the terms in ascending order. That's a precondition. Let's take another example and try to find the quartiles. In this example, there is a particular middle term. Here median is 15. There is a particular middle term, and that is 15. To find quartile 1, I'll find the median of all the terms below median. I'll find the median of the first four terms, and that is 4 here. That's our quartile 1. Quartile 2 is median itself. Quartile 3 is median of all the terms greater than the median. Median of the last four terms is 40. That is quartile 3. Now we have discussed that median is approximately at 50th percentile. So approximately 50% of the terms are below median. Now take note, I am using the word approximately. I'm not telling you that always 50% of the terms are below median. In this case, 4 terms out of 9 terms are below median. That is not exactly 50%, but it's approximately 50%. And by the way, you use the concepts of quartiles and medians when the data set is huge. In that case, it does not matter whether median is exactly at 50th percentile or it's approximately at 50th percentile. So median is approximately at 50th percentile. It means approximately 50% of the terms are below median. In the previous example, exactly 50% of the terms were below median, but in this case, it's not exactly 50% of the terms. Similarly, quartile 1 is approximately at 25th percentile. Approximately 1/4 of the terms are below quartile 1. Quartile 3 is again approximately at 75th percentile. Here, if you were asked to find interquartile range, that will be Q3, which is 40, minus Q1, which is 4, 36. Let's take another example. In this list, let's find the median. Median is 10 here. Okay, we have to arrange the terms in ascending order, which has already been done, and then find the middle term, which is 10. Quartile 1 is the median of all the terms below the median. Median of the first 4 terms is 4. Quartile 2 is median itself, and quartile 3 is median of all the terms greater than the median. Median of the last 4 terms is 10. That is quartile 3. Now here we notice something very interesting. Here quartile 2 is equal to quartile 3. So quartiles can have the same value. Let's take another example. Let's say all the terms are equal. In this case, all the terms are 10. Here the lowest value is equal to the highest value, which is equal to quartile 1, which is equal to quartile 2, or median, which is also equal to quartile 3. So quartiles can have the same values. In the particular example, here 50th percentile value is equal to 75th percentile value. Okay, in this example, 50th percentile is equal to 75th percentile. So the quartiles can have the equal values. Okay. The last concept is of stats table. Now, in one of the previous video, we had discussed stats table. In stats table, we were finding what is the change in standard deviation, range, and mean median mode if a constant is added to all the terms in the list, or subtracted from all the terms in the list, or multiplied or divided to all the terms in the list. Now I have added two things here: interquartile range and quartiles. Now interquartile range behaves the same way as range does. So if you add, subtract a constant, interquartile range will not change, similar to what range will do. It will not change. If you multiply, divide by a constant to all the terms, interquartile range will get multiplied or divided by absolute value of that constant. Now take note, range is always non-negative. Range is always positive. Hence, interquartile range is also always non-negative. So if you were multiplying a constant k to all the terms, range or interquartile range will get multiplied by absolute value of that constant, because it can never be negative. Because let's say you were multiplying minus 2 to all the terms, interquartile range will get multiplied by 2, not minus 2, because it's never negative. And quartiles behave the same way as median does. Because what is quartile 1? It's essentially median of all the terms below the median. So quartiles behave the same way as median does. If you add, subtract a constant from all the terms, median also increases or decreases by the same constant. Hence, quartiles will also increase or decrease by the same constant. If you multiply or divide a constant to all the terms, medians and quartiles both will get multiplied or divided by the same constant. Now, quartiles can be negative, so we multiply with k and divide with k. We do not multiply and divide by absolute value of k because quartiles can be negative. And with this, we come to the conclusion of this video. In this video, we discussed about quartiles. In the next video, we will continue the discussion of quartiles and we will learn about box plot. If this video was helpful, please give a like and subscribe to this channel. This really helps the channel to grow. I hope you like this video. I'll see you in the next one. Thank you for watching.